Hello everyone. So in the last video, actually we talked about data sharding, where we divide the data or partition the data between servers. Uh, there was a problem with that solution that if you have to add or delete servers, in that case, you need to distribute the whole data or redistribute the whole data. So to solve that or mitigate that issue, we have the consistent hashing. So we are going to discuss about consistent hashing. In general, when we talk about scalability, so for scalability of data, we need to have horizontal scaling capacity. It means we should be able to add the servers as per our scaling needs, whether it's for storage or for others needs. So we should be have the ability to augment our cluster with the additional host, and we need to distribute data evenly across servers. That is also one of the main requirement, that we should be able to evenly distribute the data, and not that one all the requests are coming only to one server and other servers are idle. So these are the two main needs for that, for scaling needs. So to talk about consistent hashing, before that we need to understand what is hashing. So hashing is nothing, it's a kind of a function we apply to the data or the unique request, whatever request. Let's say one user is for online shopping, he is doing some online operation. So how his request would be having some alphanumeric value or maybe some number. So we apply the hash function. As a result, we'll get some number, and then we can divide that number, or we can take the modulo of that number with the number of servers. So basically, all those requests would be mapped to the some kind of table, or we can say hash table in terms of data structure. So to make it clear, let's say we have the data request coming, R0, R1, R2, R3. So we have the hash of that request, and then let's say the number is 50025, then we take the modulo of that number. So that request would be mapped to the 1th location of this table, or based upon the different numbers, it could be 0 at 2, or the first position, if we have the number of server is 4. So uh, this was the equal distribution case. Like if we have, let's say, a lot of data, and we want to shard that data into the different hosts, then we can take the modulo of 4, and then data is evenly distributed. Why it is evenly distributed? Because 25% data is residing on each node. In this case, if we have the 4 nodes in our cluster. But what happens if we add or remove servers? So let's say one server is gone bad here. Then in that case, we have this number is 3, and if we take modulo of that number, then all the numbers would be different in this case, in this table what we were showing here. So it means that the request which was going to the first server, now it would be going to the some other server, and the request which was going to the second server, it would going to the different server. So you see all, if we change the number of servers because of addition or deletion of a number of nodes, then and this is the usual problem, right? If the requests are scaling, there are a lot of users are coming, you want to add the servers. On the other hand, servers might go bad, the power is down, or maybe some other reasons, disk is failing. So in that case, one server may also be removed from the cluster. So if you see, so in that case, all the requests would be, we need to distribute, or the data need to be distributed totally into the different server. So to cater to that issue, what we do in the consistent hashing, we have the data and request, and we have the servers. Server could be server name, or it could be IP of that server. So if we have these two things, and we pass these two things through the same hash function, then again we'll get some range of values after passing through the hash function. So suppose our this space, or what we call the term for this is the hash space. So if this is the hash space, I'm representing it horizontally, and this is the hash space. If you take this hash space and if you take it a circular form, so that is the basis of the consistent hashing. So we'll see the benefit of why linear hash space is converted into the uh, ring. We'll see the advantage of that. So in this case, actually, suppose this is the case, and we have all the requests coming, we have all the servers, and we apply the hash function to both of them, the same hash function, then and represent all those values in this uh, hash space, circular hash space, then situation would be like this. So if we have four servers, like we are talking about four servers, like S0, S1, S0, S1, I think number is little skewed here, S2 and S3, right? So we map all those servers through our hash function, because we are passing it through their server names with the hash function. So hash of name or IP would give me some value. So that value would be mapped here into this hash space. So all those servers are represented onto the ring. So that is the basis of the consistent hashing. And now, after servers are mapped onto the ring, consider the requests are coming. So maybe requests, we can take the name K, K0, K1, K2. So all these black rings are the requests coming, and all the colored ones are the host on my ring. So what happens in the consistent hashing, when the request comes, let's say K0 request is coming, so it would go to the nearest counterclockwise server. So nearest server is S1. So request would be handled by this server, or in the other words, we can say that this key would be saved onto the S1. In the same way, if there's a K1 key, if we go to the clockwise, we can say that it would be saved in the server S2, and K2 would be saved on the S3, and K3 onto the S0. So you see, all the servers are represented onto the consistent hashing ring, and keys are also represented on the ring. So this is uneven distribution on the ring, because you can say that these things may not be even, right? This So this is our hash space, and this is our hash space. So this definitely is not equal to this. So because these are the random number, our hash it's a number which is actually mapped onto the consistent in this ring, but it could be uneven server distribution on the ring. Also, there could be more skewed distribution if these servers are added or removed, right? Let's say one of the server is gone. If this server is gone, let's say S1 is gone. So now, in that case, K0 key would be handled by this S2 nearest, because this is the nearest server. So you can understand. So it would impact, if the server is removed, only it would be impacted only on the S2. All other things are remaining same, because the request would be routing it to the as usual to the remaining servers. But in case if this server fails, only these keys would be affected, and they would be routing to the different nearest servers. So I think in this mechanism, the keys are or the data distribution is uneven, but still the data movement is minimal. So we solve the problem of uneven distribution by having virtual nodes on the ring. Uh, what are the virtual nodes? Uh, so if we have the server S0 onto the ring, let's say we have S0 and S1, two servers. Yellow ones are my S0s, and S1s are red ones. So if we have one hash function h1 s0, then we'll get some value corresponding to that. And if we have another hash function s2 s3 h4, so basically corresponding to the same server, we have four hash function, and we are passing it through four hash function, and we are getting four values, and those new four values would be mapped onto this ring again. So again, corresponding to one server, there are four nodes. So out of these three, we can say that three virtual nodes we have added. And for the new one, S1, likewise, if we pass it to the four hash function, we'll have the four nodes. So what is the benefit of this? Benefit of this is that if we have more virtual nodes, we can make it the equal distribution onto the ring. So in I have shown only four here, but in the usual case, we fill it equally distributed onto the ring. So that's why the consistent hashing through virtual nodes, we achieve the equal distribution by which we started this topic, that we wanted to achieve the equal distribution and the minimal data movement if the servers are added or deleted. Um, so what are the users of this of the consistent hashing? So most of the real world distributed system, they use this. It could be in the caching layer, or it could be at the data layer as well. So wherever you have to load the data, or load the distribute the data, partition the data, we use the consistent hashing onto the cluster of hosts. And another one example is the Apache Cassandra. It's a NoSQL database. It uses a cluster of nodes, and they use consistent hashing. Um, DynamoDB, they also use the same technique. So okay, so we talked about consistent hashing, and what is the benefit of that? The distribution is evenly balanced. Distribution of data is evenly balanced on all the nodes, and reduced data movement while rebalancing. So we don't have to move the data as we have seen in the case of sharding using the simple hash function, um, and hosts are added or deleted. In that case, we needed a lot of almost all of the data distribution, and here it is reduced. So this is about consistent hashing. I hope the topic was clear, and I'll be adding more topics in the next video. Thank you.